We're going to review all of the sections of Chapter 7. So remember, we started with the idea of repeated multiplication. So let's look at a short, small table with that idea. So when we have this first one that says -6 in parentheses being raised to the -2nd power, there's two things to keep in mind here. One is that there's parentheses. And so because they're parentheses, the negative is going to be repeated with the 6. The other thing that I notice is that the exponent is negative. Remember, I can't have negative exponents. So I want to think of this as over 1, and I move that term with the negative exponent down to the bottom. So really, the repeated multiplication that I want is 1 over -6 in parentheses being squared. So because this is a fraction, that means my repeated multiplication is going to be a fraction. I'll keep the 1 on the top, and the exponent is 2, which tells me that my base, which is -6 in parentheses, needs to be repeated 2 times. So that's my repeated multiplication. If I want to simplify it, well, because it's a fraction, my answer is going to stay a fraction. Because the negative is repeated with the 6, -6 times -6 gives us a positive 36. So 1 over 36 is that simplified form. If I look at the next problem below, I've got -6 squared. However, this time there are no parentheses, and so that indicates that the negative should not be included. Because the exponent is a positive, we don't have to worry about thinking about fractions. So my repeated multiplication is I want to keep the negative, and then it's just the 6 that has to get repeated, not once, but twice. Simplified form, multiply those three numbers together, and we get a -36. So let's look at the different properties of exponents. So we want to simplify. Notice that in the first one, I've got -x to the power of 0. Remember, anything to the power of 0 is the number 1. However, in this case, because the negative is not in parentheses, it's just like that last repeated multiplication. I have to think of this problem as -1 times x to the power of 0. So once again, this term, x to the power of 0, is going to turn into the number 1. But I really then have -1 times 1. So my final simplified answer would be -1. In the second problem, I have 1 over a to the -4th power. Because I have a negative exponent, even though it's in the denominator, I can't have negative exponents. So that means I'm going to have to take what's on the bottom, and I'm going to have to move it up to the top of the fraction. With us moving that term up to the top and there being nothing else left over in the denominator, my final answer, I can keep the 1 if I want, and it's being multiplied now by a to the +4th power. So you could leave that as your answer. Because it's being multiplied by 1, you don't really have to write the 1, and so a to the 4th power is my answer. In the third one, I see that I have 3 different things being multiplied together. However, 2 of those bases are the same. I have an m twice. So I only want to have each base written 1 time. That means if I keep the m and write it 1 time, I have to combine those exponents of -7 and 2. When the bases are the same and being multiplied together, we are going to add those exponents. N to the 3rd power is going to stay as it is because there was no other n to combine with. So if I start combining -7 plus 2, that gives me -5. Because I have m to the -5th, n to the 3rd, with the different bases, I'm not going to continue adding those exponents. However, because the m has a negative exponent, we have to think of it as a fraction by putting it over 1. Only the term that has a negative exponent is going to have to move. So only the m will move, which means that we'll keep an n to the 3rd on the top, and we'll have an m to now a +5th power in the denominator. In problem number 4, I've got x to the 6th divided by x to the 7th, and then that whole thing is raised to the -3rd. So there's a couple of things going on in this problem. The first thing I see is that there's things happening inside the parentheses. Because what I see in parentheses, I've got an x on the top of the fraction and an x on the bottom. I only want to write the x 1 time. So we are going to be combining them. because it's division and the base is the same, we keep the base and we subtract our exponents. So we always take the top exponent and subtract the bottom exponent. That whole thing is still being raised to the negative third power. So if I continue then to subtract those exponents, 6 minus 7 is going to give me a negative 1. That's still raised to the negative third power. But now I don't have more than one of the same base, so this is nice. So I only have x one time. And now I notice that I have a problem where I have a power raised to a power. Remember, when I have a power raised to the power, I keep the base and I want to multiply those exponents. So when I multiply negative 1 times negative 3, I'm going to get positive 3. And because this is a positive exponent, we don't have to worry about moving it. So that's my final answer. If I look at this next problem where it says to solve the equation, we have b to some power raised to the 9th power, and that equals b to the 3rd. So I want to figure out what this exponent is. I'm going to call it x. Notice how this is just like the last problem where I have a power to a power. Because these bases are both the same, I then essentially get to forget about those and I want to deal with the exponents. Power to a power means multiply. So x times 9 is really the same thing as 9x. That equals 3. My goal is to solve for x because that's the unknown exponent that I'm looking for. So because 9 is being multiplied, to undo multiplication, we are going to divide. Notice that in this case, 3 divided by 9 is going to give you a decimal, so just reduce down the fraction. Both of these are divisible by 3. 3 divided by 3 is 1, so I'll have a 1 on the top. 9 divided by 3 is 3. So it looks like that missing exponent was 1/3. So those are all my exponent rules. Let's take a look at a graph. So if I want to graph this function, y equals 1/3 times 3 to the power of x, notice that we are going to substitute in these values for the exponent. So we're going to have 1/3 times 3 to the 2nd power. We're going to have 1/3 times 3 to the 1st power. We're going to have 1/3 times 3 to the power of 0. We'll have 1/3 times 3 to the negative 1st power, and we'll have 1/3 times 3 to the negative 2nd power. Okay, so you can feel free to use your calculator. If I was to take 1/3 and multiply it by 3 squared, that is going to give us 3. So that means my ordered pair is the ordered pair 2, 3, because 2 was the x value we substituted in, 3 was the y value that we found. If I multiply 1/3 times 3 to the 1st power, well, that's going to give us 1. So our next ordered pair is 1, 1. If I have 1/3 times 3 to the power of 0, well, that's going to give us 1/3. As a decimal, that would be 0.3 repeating. So we would have 0 and then 0.3 repeating. When I have 1/3 times 3 to the negative 1st, that's going to turn into 1/9, which is essentially 0.1 repeating. So, we plugged in negative 1, so negative 1, and then 0.1 repeating. And then finally in this last one, if I have 1/3 times 3 to the negative 2nd power, that's going to turn into super small fraction. This is going to give us 1/27, which as a decimal is 0.037, so on and so forth. So that would give us -2 and then 0.037. All right. So once I have my ordered pairs, I'm going to start plotting the points. So I go over to 2 because that's on the x-axis, and then I go up 3 because that's on the y, and I can plot my point. 1, 1 would fall right here. I'm going to zoom in a little bit here. We want 0 and then 0.3 repeating. So 0.3 repeating is going to be halfway, or not halfway, but 1/3 of the way between 0 and 1. So that's going to be estimate around here. When I plugged in -1, I got 0.1 repeating. So that's going to be even smaller, getting closer and closer and closer. If I had -2, it's even smaller, getting very, very close to 0. So essentially then I'm going to be continuing to get values that are going to get closer and closer to 0 on the left. And then on the right, they're going to shoot up and get bigger and bigger and bigger. So this would be my graph. All right, last concept would be our interest problems or growth and decay problems. So remember, here were our 3 different formulas. When we're growing, we're thinking about adding, okay? Anytime we see the word, increase, like we said, obviously grow, that kind of thing is going to be growth. If I'm talking decay, it's because we are decreasing or we have a decay, or if we have depreciate. So lots of different words there that help me with getting smaller. So we're subtracting. Compound interest is anytime we see that word compound. All right, so let's take a look at this one problem. It says a TV's local news program has 112,000 viewers. The managers of the station hope to increase the number of viewers by 2.5% per month. Find the number of viewers the station will have after 5 months if the increase is able to occur. So the fact that we are talking about an increase, well, increase, like over here, we are growing. So I want to use this model. So that means I need to identify the P, the R, and the T. Remember, P stands for the initial amount. So that would be that we had 112,000 viewers. We are dealing with a rate of 2.5%. We have to write this as a decimal. So either divide that by 100 or move the decimal 2 places to the left. So that's 0.025. They're asking about 5 months for my time. So if I plug this information in, 112,000 times 1 plus 0.025 raised to the 5th power. So I'm going to very carefully type this into my calculator, making sure that I don't lose the parentheses. I make sure that the 5 is written as an exponent. And it looks like in my calculator, I'm getting 126,717.7198. So now this is where we have to be careful. We're talking about the number of viewers. Viewers are people. There's no such thing as 0.7 of a person. So this time we are going to round to the nearest whole number. And the fact is, because it's point something, I'm going to round this 7 here up. So we really have 126,718 viewers.